In this question, we need to find the relation between the frequency and time and amplitude and time of a leaking mass spring system in the form of a graph. We know that omega equal to root over k by m. Now here's the tricky part, because ideally we can't really use this formula because this mass here is time dependent, right? Because it is leaking. And we need to solve some complicated differential equation which is beyond the scope of NEET. Now NTA maybe want us to use these standard results and arrive at some conclusions, and that's what we will be doing. So here evidently omega is proportional to 1 by root under mass. So if mass increases, omega decreases, and mass decreases, omega increases. Now here in the system the mass is leaking. So with the decreasing mass, omega will be increasing. So in option 1, omega is increasing, option 2 it is increasing, option 3 increasing. In option 4 it is decreasing, so it is eliminated. This option is eliminated here. Now total energy of a spring mass system is Ke plus P, kinetic energy plus potential energy, right? Now at extreme positions, we know that kinetic energy is 0. The potential energy will be equal to half kx square. Again, it is, remember, it is I'm talking about extreme position. So x will be equal to a, that is the amplitude. So the potential energy will be half k a square. So the total energy will be equal to 0 plus p, that is half k a square. Because kinetic energy is 0 and potential energy is half k square. Let me write it once again. So here we are seeing a direct relation between energy and amplitude square. If energy increases, the amplitude square increases, so does the amplitude, of course. And if energy decreases, the amplitude square will decrease and amplitude will obviously decrease. Now our main concern is to know, because we want to find a relation between amplitude and time, right? So we need to know what is happening to the energy with time due to the leaking of mass. Let's say 3 friends, okay? 3 friends, mass m, of all of them have mass m, is traveling holding hands because they're friends. All of them are traveling with velocity v. Now this is the total system of the 3 mass. So the total kinetic energy will be half into 3m into v square, the basic formula. Now if one of the friend gets gently detached from the other friends, that is from the total system, all of them are still traveling with the velocity v, right? There is no force involved here. They just the third mass actually gently got detached. But the system is now reduced to the 2 friends now. So if we compare the energy between the systems, the kinetic energy of the the latest system has decreased, obviously, because it has only 2 mass now, and the kinetic energy now is half into 2m into v square. I'm saying all of this because here in the question the mass is leaking. At the instant of leakage, velocity of the leaking sand is exactly same as the remaining sand. So there is no thrust like it happens in the case of rocket propulsion, right? There the velocity of the gas is different from the velocity of the rocket. Here at the instant of the leakage, the velocities are the same. What happens to the leaking sand afterwards is not our business. That's beyond the scope of this sum. So it's exactly like the 3 friends situation, and the system gets reduced here also. So in the spring mass system the energy will decrease, like in that case, that analogy that I just gave. And if the energy decreases, so will the amplitude, and Option B will be the correct.